Today we're going to talk about random variables. A random variable is a variable that assumes its values randomly. From your book, a random variable takes values based on the outcomes of a random event. Random variables are denoted by a capital letter such as X, Y, etc. The values of these random variables are denoted by corresponding lowercase letters. Let's look at example 1. Let X denote the outcomes of a single roll of a fair die. Since roll in a die is a random event, X is a random variable. X assumes the values 1, 2, 3, 4, 5, or 6, each with a probability of 1/6. So this that we have here is our probability model. So this entire table is our probability model. So the outcome of roll X, 1, gives me a probability of 1/6, 2, a probability of 1/6, so on. Each one has a probability of 1/6. So this is the probability that our random variable X takes on, 1/6. So let's say that I wanted to know the probability that X equals 3. The probability that X equals just 3 is 1/6. Say I wanted to find out the probability that X is less than or equal to 3. Less than or equal to 3 would be 1/6 for if I get a 3, because it's equal to, plus 1/6 if I get a 2, plus another 1/6 if I get a 1. So that would be 3/6, which is the same as 1/2. But the probability that X is less than 3 does not include 3, so it would be different. It would be 1/6 for the 2 plus 1/6 for the 1, which would give me 2/6, which is equivalent to 1/3. But you are free to leave it as 3/6 and 2/6 if you would like. Discrete random variable. A random variable with a set of all possible values that can be listed out. The above table represents the probability distribution for discrete random variable. The distribution lists all possible values for the random variable and the associated probabilities. We will look at binomial and geometric random variables as our specific examples of discrete random variables in Chapter 17. Let's look at example 2. A consumer organization inspected new cars found that many had appearance defects, dents, scratches, paint chips, etc. While none had more than 3 of these defects, 7% had 3, 11% had 2, 21% had 1 defect. Let random variable X be the number of appearance defects in a new car. Find the probability model for X. So in your textbook, this is number 17. So the number of defects that they talk about are 0, 1, 2, and 3. The probability that there are 3 defects is 0.07. The probability that there are 2 defects is 0.11. The probability that there are 1 defect is 0.21. And then 0 defects would be 1 minus that, which is 0.61. This is your probability model. So when they ask for a probability model, you make a table of what they're looking at and the probability of those. Let's look at example 3. You play 2 games against the same opponent. The probability you win the first game is 0.4. If you win the first game, the probability you also win the second game is 0.2. If you lose the first game, the probability you win the second game is 0.3. Let random variable X be the number of games you win. Find the probability model for X. What are the expected value and standard deviation of X? So this is problem number 19 in your textbook. Let's start by looking at our probability model. We know the number of games that we could have won are 0, 1, and 2. Then we need to find the probability that we won 0 games, 1, or 2. Let's start with the probability that we won both. So the probability that I win both would be the probability of a W for the first game times the probability I win the second game given I win the first. So the probability I win the first game, they said, is 0.4. If I won the first game, the probability I also win the second game is 0.2. So the probability that I win both is 0.08. Let's go ahead and look at the probability I lose both. So it's the probability, my first one is an L, times the probability my second one is a loss, given my first was also a loss. So the probability that I lose the first one is 0.6 because it's 1 minus 0.4 based on the first game. Times the probability that I lose the second given I lost the first, and that would be 0.7. Because if I lose the first game, the probability I win the second game is 0.3, so 1 minus 0.3 gives me 0.7. I multiply those together, and I get 0.42. And then the probability that I win one game would be 1 because all these probabilities have to add up to 1 minus my 0.42 plus my 0.08. And that would give me 0.5. So now I have completed my probability model. I need to use my probability model to find my expected value and my standard deviation. First, to find my expected value, which is mu, and that's my expected value of x, it would be 0 times 0.42 plus 1 game times 0.5 plus 2 games times 0.08. So the expected value should be 0.66. So my mu would be 0.66. Now, in order to find the standard deviation, you first have to find the variance. So we're going to find the variance first, and then take the square root of that to find the standard deviation. So my variance would be, I take my number of games won minus my expected value, square it, and multiply it by the probability. And then I would do the same thing. I'd add that 1 game minus my expected value squared times the probability of winning 1 game plus 2 games minus my expected value squared times the probability of winning 2 games. And I would take and add all of these together, and you can do this horizontally as well. I just didn't have enough room. And you get 0.3844. So that's my variance. In order to find my standard deviation, that's just sigma. So my standard deviation of x would be the square root of 0.3844. And that would just be 0.62. Continuous random variable. A random variable with its set of possible values being any numerical value within a range of values, so within an interval. We will look at the normal random variable as our specific example of continuous random variable in chapter 6, the next chapter that we're going to do. But let's look at an example. So in example 4, randomly choose a real number between 0 and 1. If x is the random variable that represents the values between 0 and 1, then x is a continuous random variable because you have an infinitely many number of variables. So what's the probability that x equals 1/2? So with this, you want to ask yourself, this you can actually visualize like a calculus problem. So can you see the calculus for those who have taken calculus? And hopefully those who have taken calculus are thinking integrals. And then what must the height of the rectangle be? So what must the height because my interval goes from 0 to 1. So my height of this would have to be 1. So the rectangle that you're thinking about with your integrals would be this rectangle here. And the rectangle will be the legitimate probability assignment because its area is 1 because it's 1 by 1. Okay, so its entire area is 1, so its entire probability will add up to 1. So if you're thinking about this with calculus, which you won't have to do on any of your quizzes, the probability that x equals 1/2 would be my integral of my function from 1/2 to 1/2 of f of x dx, which equals 0. If it was less than or equal to 1/2, it would be from 0 to 1/2 of my function, and that would be 1/2. If it was just less than 1/2, it would also be from 0 to 1/2, and my area would be 1/2 for that. But you're not going to have to do this on any of your quizzes or tests. So let's look at center and shape of a discrete random variable. Mean of a discrete random variable. The mean of a discrete random variable gives a long-run average expected outcome. The mean represents an average of all possible values weighted by associated probabilities. This is the measure of the center of the probability distribution random variable, x. My expected value x, which is mu, is the sum of x times their probability. This formula is on your formula sheet. We use mu for mean instead of x bar as we did with data because mu is a model parameter and not a mean we are estimating from data. In the book example, mu would represent the long run expected number of games won. So we're going back to the book example of number 19 that we previously did. So my expected value of mu that I found, I took 0 games times 0.42 plus 1 game times its probability of 0.5 plus 2 games times its probability of 0.08 to get 0.66 games as the expected value. So you can expect to win in the long run 0.66 games if you continue to play upwards of 100 to 1,000 to 100,000 games. Variance of a discrete random variable. The variance of a discrete random variable is the measure of the variability in the probability distribution of random variable x. Our variance is the standard deviation squared, and this formula is also on your formula sheet. In the book example that we did, talking about the games in the previous example that we did, it would be 0 minus 0.66 squared times the probability, which was of 1 in 0 games, 0.42, plus 1 minus 0.66 squared times the probability of 1 in 1 game, which is 0.5. Plus 2 games minus my expected value times the probability of 1 in 2 games, which is 0.08. My variance ended up being 0.3844 games. And the standard deviation would just be taking the square root of 0.3844 to get 0.62 games. Remember, you can use your formula sheet at any time, but you do need to show the work to find the variance, standard deviation, and expected value in problems.